Thank you for the introduction. It's actually the best introduction I've ever had, so yeah, appreciate it. Hello everyone, and I know this is the end of the day, and I guess everyone is tired already, but this talk, I guess, will be tough. I have 80 slides, and to fit in, I need like 30 seconds per slide. I hope I can fit in the time range. Also, we are going to have examples of encoding, serialization, binary data, and this kind of stuff. So I hope you're ready for it. Yeah, this is a slide with some information about me. Here you can see my favorite photo of myself. I work as a lead web developer at Oletskaya. This is outsourcing company in Minsk, Belarus. I'm open source contributor, and here you can see some links on my social networks. Let's start with defining our terms. So first, what is RPC? RPC is a remote procedure call. It's a protocol that one program can use to request a service from another program located on another computer. The term itself is not new at all. Actually, first it was described somewhere in the 70s, and RPCs widely used in terms of distributed programming. But in recent years, it started to become more and more popular in the context of web development, I guess, together with the popularity of microservices architecture. And here comes a story why in the first place I decided to give this talk. The story is next. I was working like for the last 2 years on a really big project consisting from more than 50 services. And we were migrating our system from internal RESTful JSON API to RPC-based communication solution. Here is an example how did it look before the migration. It's actually much simplified example, just to give you a basic idea. So here you can see at the end AWS Lambda, it sends RESTful JSON request to some endpoint for managing service. I'm not sure if you can see. Well, okay, doesn't matter. So managing service is kind of entry point, and then it sends RESTful JSON request via our internal API to other services. Also, we used to have NAT streaming as a messaging queue. And this is what we received our migration. We also changed a bit our stack, so now we are using Amazon messaging queue as a queue. And in the center of the scheme, there is an RPC server which holds connections with our services, and they communicate via RPC protocol. This may seem as a single failure system, but single point of failure system. But actually it's not. I was just too lazy to draw it. But we are using HashiCorp stack, and we are using service discovery, and it actually scales. So usually in time of work we have several instances of RPC server. And at this moment, probably some of you may want to ask, why did we need it? What is the purpose of it? And the answer consists from several parts. First one is performance, because RPC comes with faster serialization, because XML is kind of slow. JSON is convenient, but also relatively expensive. Next one is latency, because we wanted our services to talk directly to each other and know through a reverse proxy. And well, now we have a keep alive connection. And simplified versioning, because all our services now have shareable schema definition, and it becomes easier to make it backward compatible or to add new changes to each of the service. At this point, we can define what is RPC framework. Usually it provides client and server, which helps to implement serialization and all the connection management for you. And we need to keep in mind that RPC frameworks usually are not monolithic. They consist from well, like collection of technologies where you have options like which technology you would like to pick for transport or which technology you would like to pick for serialization. And in 2019, there are quite a lot of options, such as gRPC, Twips, Rift, Kappen Proto, Finagle, Daba, Avro, and many, many others, which didn't fit into this presentation. And we are going to have a really quick overview of each one, pros and cons for each of the frameworks. First one is the most trendy one, gRPC. This one is actually backed up by Google Corporation. It's implying usage of protocol buffer-based services definition. Also, it provides automated generation of server and client stubs, bidirectional streaming, and other features. By the way, yeah, spoiler alert, this is actually the one that we are using on our production service. When it comes to implementations, gRPC comes in different technologies. The placed for Java, Golang, Python, and C++, and the rest C#, Dart, Node.js, WebJS, Objective-C, PHP, and finally Ruby. So what does it mean blessed for? It means that for these 4 languages, all updates, all security fixes, and well, this kind of stuff getting released firstly, and the rest is waiting till Google team has the time for these technologies. For example, on our project, when we migrated from Ruby 2.5 to Ruby 2.6, we were need to wait like maybe 2 weeks till there was released an update in protobuf library. And these 2 weeks weren't, this is not too much actually, it's very crucial for our team, but it's definitely something you need to keep in mind. As a transport, gRPC provides the next options. HTTP2 is default. Next one is Coronet. It's a Chromium network stack made available for Android apps. And the last one is in process. This one you can use when you have client and server within the same process, so your instances can send messages directly to each other without serialization step. And here are gRPC protocols. In terms of RPC frameworks, protocol usually means serialization. So it supports protobuffers, flat buffers, Kappen protos, Rift, Avro, JSON, and raw bytes. We will look in more details at protobuf, because this is also the most popular and the one which is used on default. So this one guarantees type safety and backward compatibility, prevents schema violations, fast serialization, and usually it's much smaller than JSON or XML. Here's a protofile example. So you can see that it's quite similar to JSON. Well, at least it looks somewhat similar. No, it's not similar, but it reminds me of JSON a little bit. So in the top of this file, you can see messages definition, and within messages, you can define several fields of different types. And well, so you should provide data type, then a field name, and then unique identifier. And this identifier should be well, unique in the context of this message. And in the bottom of the file, you can see services definition, which provides signature of methods, which data each function takes, and which data it returns. And now let's dig into more details. How does protobuffers work? Usually it will work for you as a black box, so you don't need really to know how does it work, but well, we are all engineers, and at least for me, it was, I was kind of curious how exactly it encrypts the data so it becomes much smaller than JSON. So let's try to take a really quick view on it. So let's imagine that we need to encrypt, not to encrypt, to encode content hey of this message type. So for the hey, we will receive the next byte sequence, 5 bytes here. And in binary format, it looks like this. The first byte in the stream always contains a wire type key and a field ID. So first that we need to do is to drop the most significant bit. The most significant bit is the first bit in byte. And it means that, well, in case if the information didn't fit in the byte, in a single byte, then the most significant bit will be 1, and we need to read the next byte as well. So we need to read the bytes till the most significant bit is 0. But in our case, most significant bit is already 0, so we can stop it here. And in the rest field that we have, it contains like field number and wire type. Wire type is the last 3 bits, and the rest is field number. Now we can take a look on a table which contains definitions of types. In our case, it's 2, length delimited type, which contains string. And the field number is the rest, it's 1 in our case. The second byte contains the length of the length delimited type. This is the 3 amount of bytes to read. And the rest contains the encoded UTF-8 value. I hope you could follow my idea, but well, it provides a bit different encoding techniques for different types of data, and that's how it works for length delimited string. Yeah, so it's ID 1 and content hey. Now let's compare it to a regular JSON REST request. So here, like, we are trying to send content hello, and we can see like regular GET request and HTTP response, only 2 requests. And the file data is 25 bytes. And now let's compare to gRPC example. So here is much more some like helper requests which contain some magic settings and headers, pings to keep this connection live. But the data itself is 13 bytes. So the data takes less space, but there are much more activity on the network. So you should keep in mind that in case if you send rare small messages, it may not, it doesn't make really sense to you, doesn't make sense really, to switch to gRPC. But in case if you're sending frequent messages, and in case if they're big in size, then yeah, you can save a lot of bandwidth. Also, gRPC comes with protocompiler. This compiler generates client and server code for you based on the proto file. In case of Ruby, this is a Ruby library, which is named gRPC tools. So here is a dir structure of files that it generates. Well, you only showed it to compare with then later other frameworks. So you can see gRPC proto file in the root, and then generated files next. It generates files with messages definitions. It's gRPC x protobuffersrb, and the next one, gRPC x services protobuffersrb, which contains definition of services. Also, client and server is well, the files that you need to write yourself. And here's the after generated code is pretty small. When it comes to pros, I can name great documentation, really. It's very detailed, so you can find all edge cases, explanations, a lot of, well, besides great documentation, it also has a giant community, a lot of questions on Stack Overflow you can find, or maybe some articles, and you can find help for you. Also, it comes with HTTP2, which is also great, and the killer feature is full duplex communication. Actually, it means that you can send messages from client to server and vice versa. This is the only one framework which comes with this feature. And when it comes to cons, it's about, well, the issues. There are a lot of bugs, and also I can name one other concern. Is that it works with HTTP2, so it can't work with load balancers, because most of the load balancers support only HTTP1 protocol. So, well, at least in our case, we are on HashiCorp, and we use our own service discovery and our not so smart load balancing when it just randomly switches between services. So it works for us, but well, it may be not the case for some other people. And when it comes to load balancing, I should mention TWIRP. This is the next framework that we are going to overview. This one is backed up by Twitch. By the way, the funny fact is almost all RPC frameworks are backed up by some big corporations or companies. So usually big guys develop this kind of stuff. So TWIRP was designed specifically by Twitch team because they wanted to use gRPC, but with Amazon load balancers. So they wanted to do it the same, but with support for HTTP 1. Here's a list of implementations, and it supports both clients and servers support Ruby. For a transport, there are not so many options. For HTTP, it supports HTTP 1 and some limited features of HTTP 2, and protobuf for serialization. The structure for project is absolutely identical, as you can see. So, well, for you as an end user, it's very similar. I have the generated code examples here. When it comes to pros, well, all articles that I've seen describing TWIRP, all of them name it a better gRPC, but actually, well, I'm not sure if we can agree with this, because well, it's just the same as gRPC, but with support for HTTP 1. And for cons, well, as they need to support HTTP 1 in the same time HTTP 2, so they can't do full duplex streams. Next one, Apache Swift. This one actually is the oldest one and is backed up by Facebook. And Facebook in their time made a very wise decision because they decided to make this thing open source. I think it became open source in 2020, but 2012, sorry. But I'm not super sure. Maybe so for about 7 years it's been open source. And due to this fact, well, a lot of companies are using this solution. And there is a legend which says that a lot of years ago there was a Google intern that was working in Google in Stubby project, which kind of ancestor of a gRPC, or not ancestor, but vice versa, parent of gRPC. And this intern didn't manage to finish his internship, and he quit, and Facebook hired him. And he provided a lot of code from Stubby, and so basically Swift also is based on the same idea and the same code base as gRPC was. And yes, they are quite similar also. There are a lot of implementations here due to the fact that it was open source for quite a long time. It's not the full list. So a lot of different options and different technologies. For transport, Swift comes with a lot of its own technologies, like the default on is T-socket, which uses blocking socket I/O. And also you can use even file to, well, or memory directly, so yeah, a lot of possible decisions. For protocol, it's the same. They also develop a lot of their own versions of Swift protocol for serialization of data. Swift file looks really similar to .proto file. It, instead of messages, here are structs with also unique identifier of field and their data type. And the service at the bottom of the file. Also, you can quite feel something similar. Swift provides its own compiler, which generates client and server code based on the .swift files. The structure also. really similar. And when it comes to Swift prose, it goes with wide languages support. So in case if you have a really big services system with a lot of different technologies and you want to link themselves via RPC, probably it will be the best choice for you. Maybe if you are using Rust or Dart or, I don't know, some not very common used technology. And another one, I'm not really sure if it's a prose, probably it's prose. People now say that Swift is not so trendy anymore, so everyone is using gRPC instead, but Facebook currently works on a new version, which is named Phoebe Swift, so there will be some updates soon. When it comes to cons, Swift has really poor documentation. And it's quite surprising because it has a giant community and it's been live for quite a long time, but they didn't manage to provide, fine documentation, so it's really hard to find anything to, in case if you are trying to do something custom. I made some code samples. Firstly, I was going to make a code sample for each of the framework, but then I decided I'm too lazy for this, so I made code samples only for the first 3 in my example. You can find it here. Yeah, we are going next, and the next one is Cap and Proto. It also comes with a story. Former tech lead for protocol buffers quit Google at some point and led Cap and Proto. So it's also kind of based on the same idea. On the main page, it says that it's extremely faster than gRPC because it doesn't use encoding at all. And it's kind of a trick, just a marketing image, because it still uses serialization. So what is the difference between encoding and serialization? Encoding usually means that you convert your data from one presentation to totally another presentation, and serialization, by another presentation I mean that you change the values. And by serialization, it usually means when you have some structs and you want to make them flat and convert to strings. So Cap and Proto still uses serialization, but that data is arranged with fixed width, fixed offsets, and proper alignment, meaning that usually messages that you send via Cap and Proto will be longer, much longer compared, for example, to gRPC. When it comes to implementations, it supports, there are implementations for serializations plus RPC and also implementations which provide serialization only. I honestly tried to run it for Ruby, but the latest update was 6 years ago, and also it has a fork with RPC implementation, which was with the latest update like 3 years ago, and I tried to run it, but in the make file it has a hard-coded version of GCC, and now Cap and Proto library requires higher version, so it just doesn't work. So at this point we finished it with the RPC frameworks, which are really similar, and now we can go forward to some fresh new ideas. And the first one is Finagle. This one is a transport agnostic system for JVM made by Twitter. Supported protocols uses a bit different definitions, so it doesn't care really about transport, and it supports MAX, Swift, MySQL, HTTP, and for example, by MySQL, it means that you can install your client directly into your database and call services from network directly on your database. Like example. The idea behind Finagle is fully async threads. It's based on, well, first of all, Finagle is implemented in Scala, and it uses features in Scala. And features are somewhat similar concepts to JavaScript promises or for Ruby fibers, for example. And in theory, it should support all JVM languages, JRuby included. I tried to find implementations in JRuby, or maybe some people who have used Finagle together with JRuby, but I didn't. And I suppose, well, that it won't really work with Finagle because JRuby has limited support for fibers, and the whole idea behind Finagle is asynchronous stuff, so probably it won't fit together. But there's still an open opportunity, so in case if someone from you guys who wants to try it, you can go ahead and and give it a try. Next one is Dubo. Dubo is made by Alibaba. It's a Chinese version of Amazon. Currently, it's in incubating stage, and it is a high-performance Java-based RPC framework. It is the most complicated from all of them because it involves a lot of abstractions, such as consumer, provider, container, registry, and this kind of stuff. It even comes with its own UI, where in monitor you can kind of track how many messages did you send, and I don't know, track some other stuff. Here is a list of protocols which are supported. Dubo, HTTP, RMI, and so on. Implementations are ready for Java, Golang, Python, on the client yet, Node.js, and PHP. So no Ruby support yet, but who knows, maybe soon. And next one is Apache Avro. Avro is backed up by Hadoop project. Key features are dynamic typing, and schemas are defined in JSON. It means that when it starts to send data, it firstly sends a schema, and then it tries to deserialize your data based on JSON schema that was sent first. Usually, this one is used for some big data tasks. It has Ruby implementation as well, and as well as C, C++, C#, Go, Haskell, and others. So benchmarks. Actually, there are quite a lot of different benchmarks on the web for each of the RPC frameworks in different combinations, but they are all very, how to say, opinionated, because different benchmarks compare different parts of framework, like some of them compare bandwidth, some of them compare speed of encoding, or some other stuff. Also, we need to keep in mind that RPC frameworks have support to different technologies, so in different benchmarks you can choose like HTTP1 or HTTP2, one way of serialization or another way of serialization, and depending on that, the benchmark will be totally different. So yeah, it's the RPC framework which will fit for your needs really depend on your problem. So what is the bottleneck of your application, like the bandwidth or maybe the CPU or something else. And yeah, and I need to mention distributed Ruby, DRB. It was popular a long time ago, and it's still alive. Actually, I know that it's actively being used in Red Hat. As well, as in Rails 6, there is a new feature named parallel tests, which uses distributed Ruby. So in case if you have several Ruby processes, it's actually a nice thing to play and to send messages. And yeah, that's it. I think I was trying to fit in my 40 minutes, so I finish it even faster. So yeah, thank you.